All right, let's dive right in. Over the next few minutes, we're going to break down the essential calculations that, frankly, separate a cadet from an officer. This isn't about passing a test. This is about the real-world, high-stakes decisions you'll be making on watch. So, let's get to it.
So, I want you to picture this. You're the officer on watch. The pumps are humming away, and you are responsible for loading over 800 tons of fuel oil. You get the calculation right? Hey, it's just another day at the office. But get it wrong by even a little bit, we are talking catastrophic overflow. We're talking environmental disaster. We're talking massive, massive fines. This is your mission.
Okay, so here's our game plan. First, we'll set the mission, then we'll grab our core formulas. We're going to decode something called ullage, tackle the super important expansion safety rule, run a final check, and then, at the very end, I'll hook you up with a master cheat sheet you can take with you.
So first things first, why should you even care about this? Well, because these aren't just questions you'll see on an exam and then forget about. No way. These are the tools you'll use every single day to keep things safe, efficient, and legal on board. Getting this stuff down cold, that's what makes you a competent officer.
All right, every mission needs the right tools, right? So let's build our toolkit. We're going to start with the absolute fundamentals.
Okay, everything, and I mean everything, starts with density. That's just the mass per unit of volume. And for us, there are two key benchmarks you got to know. Fresh water, which is a nice clean 1 ton per cubic meter, and then salt water, which is just a little bit heavier at 1.025. Think of these as your North Star.
Next up is relative density, or RD for short. Look, all this is a simple ratio that compares something's density to fresh water. And here's the beautiful part, the little life hack you need to remember. Since fresh water's density is 1, the RD number is literally the exact same as the density in tons per cubic meter. Super simple, right? We're going to be using this little trick all the time.
And here we go. The two golden formulas. I'm telling you, these two will solve almost any cargo problem you'll face. First, weight equals volume times density. Easy. Second, for a simple box-shaped tank, volume is length times width times, wait for it, this is the important part, the depth of the liquid. I have to say that again, the depth of the liquid, not the total depth of the tank. Forgetting that one little detail is probably the most classic rookie mistake in the book.
Okay, let's talk about the single biggest trip-up for new officers. Seriously, it's confusing ullage with sounding. If you can get this one difference locked in your brain, you are already way ahead of the curve.
So, what's the deal? It's pretty simple when you see it. Ullage is the empty space. You measure it from the top of the tank down to the surface of the liquid. Sounding, on the other hand, is the actual depth of the liquid itself, measured from the bottom of the tank up. And for all our math, for all our formulas, we always need the sounding. Always.
All right, enough theory. Let's put this into practice. Here's a problem for you. You've got a tank, you know its dimensions, and your tape gives you an ullage of 1.5 meters. The oil's RD is 0.88. So the question is, what's the weight of the oil in that tank right now?
Let's walk through it together. First step, and it's the most important one, we have to turn that ullage into the liquid height, or sounding, that our formula needs. So we take the total tank depth, 8 meters, and subtract the empty space, that 1.5 meter ullage. That gives us a liquid height of 6.5 meters. Now we're in business. We can calculate the volume, which works out to 1,170 cubic meters. Last step, just multiply that volume by the density, 0.88, and boom, there's our answer, 1,029.6 tons.
Okay, let's talk about the rule that keeps you out of trouble. The rule that protects your ship, your career, and the ocean. It's all about expansion. See, liquids get bigger when they warm up. And if you don't leave a little empty space for that to happen, well, you're going to have a really, really bad day. This isn't just some abstract math problem. This is a non-negotiable safety protocol.
Okay, I need you to lean in for this one, because the specific wording of the rule changes everything. It's a classic exam trap, but a real-world disaster if you get it wrong. If the rule says you need to leave, say, 2% of the tank empty, that's easy. You just multiply the tank volume by 98%. But if it says you need to allow for 2% expansion of the oil, you have to work backwards. You take the total tank volume and you divide it by 1.02. Mixing up whether to multiply or divide is such a common mistake, and man, it can be a costly one.
Alrighty, this is the big one, the final boss. We're going to pull everything together now, everything we've just talked about, to answer the single most important question you'll face during a loading operation. When do you pick up the radio and say, "Stop the pumps"?
So here's the scenario. You've got a deep tank, 16 meters long, 10 wide, 6 deep. You're loading an oil with a relative density of 0.95, and the safety rule is very specific. Allow for 3% expansion of the oil volume. Remember what we just said about wording? This is key. So based on that, you need to find out two things, two critical pieces of information. Number one, what is the maximum weight in tons that you can safely load into this tank? And number two, what is the final ullage? I mean, what number exactly do you need to see on your measuring tape to know it's time to stop?
Okay, let's crunch the numbers. First step, easy part. Get the total volume of the tank. That's 960 cubic meters. Now, remember the rule? It was 3% of the oil. That means the total tank has to contain our oil plus its 3% expansion room. In other words, the tank represents 103% of our cargo's volume. So what do? We divide. We take 960 and divide it by 1.03. That gives us our maximum safe volume of oil, 932.04 cubic meters. From there, it's back to our golden formula to get the weight.
And there you have it, our first answer. The maximum you can load is 885.44 tons. But here's the thing, you don't have a giant scale on the dock, right? You can't weigh the oil as it's coming in. You need a physical measurement. You need a number on a tape.
So that brings us to part 2, finding that final ullage. How do we do it? Well, first we figure out how high that safe volume of oil will be in the tank. We just take our oil volume, that 932.04 number, and divide it by the tank's footprint, its length times its width. That tells us the oil will be 5.825 meters deep. Almost there. Now we just subtract that liquid depth from the total tank depth of 6 meters, and that gives us the empty space at the top, our final ullage.
And that is the magic number, 0.175 meters, or 17.5 centimeters. That is the single most important piece of data you need while you're on watch. When your tape hits 17.5 centimeters, you get on the radio and say stop. Mission complete. Job done right.
All right, mission accomplished. So what's the takeaway? Let's do a quick debrief and pull all this together in one simple, powerful tool you can use anytime you need it. And here it is, your master cheat sheet. You've got your basic mass formula, you've got the critical reminder to always convert ullage to liquid height first, and, most importantly, you've got the 2 expansion rules laid out side by side, telling you exactly when to multiply and when to divide. Seriously, screenshot this, write it down, keep it handy. It's everything we just covered.
And just to put a fine point on how critical this is, let's look at a quote from the source material. It says it flat out. Stop loading when the tape measures an ullage of 17.5 centimeters. It goes on to say that if the ullage is less than that, you've overfilled the tank. Think about that. This isn't about getting close enough. An ullage reading of 17 centimeters means you failed. 17.5 means you succeeded. The margin for error is literally millimeters.
So, there you have it. You've seen the theory, you've run the numbers, and you've seen how it all translates into direct, critical action on deck. You've officially completed the mission, on paper, at least. So the only question left is, are you ready for the real thing?